All right, this is section 9.6. It's going to be short and sweet. We've only got 5 problems. I'm just going to show you how to solve equations using radicals. So there's not, not a whole lot that's new in here, except for the fact that we have something called extraneous solutions or extraneous roots. Where's my pen? There we are. Okay, so these are just a concept that says that when we do any kind of solving with radicals involved, they produce solutions that don't work once in a while. Not always, but once in a while. So here you have to check everything to see if it works, because some of the answers we're going to throw out just because they don't make true statements. So that's basically it. When you're solving with radicals, you always want to isolate your radical on one side. This one is, right? I've got the radical on one side and I've got everything else on the other side, when they're nice and easy like this. Okay, so I'm solving for x, but it's underneath a square root, so what would I do to get rid of a square root? Well, I do the opposite, which is squaring. Right? Because the square root of a square is itself. So then this x minus 6 can come out. It's this principle right here. Okay? But if I square this side, I have to square that side. I'm always doing the same thing to both sides of the equation. Okay? So the square root of a square is itself, so that comes off. And now 21 squared, who knows what that is? I don't know what that is. 441. Okay, now I'm solving for x, so I would add a 6 across. Gone, so x is equal to 447. Well, let's check it. Let's do the second function, square root of 447 minus 6 is 21. Nice. All right. So we'll put that in there. Whoops, I can't hit it. There we go. All right. All right, so here we want to isolate the radical. This one's not isolated. Okay, so here's my radical. I want to subtract my 9 across so it looks more like that first problem. So I have x plus 10 is equal to a negative 9. Now, how does this work? Let's see, we've got a radical and we want to get rid of it, so we're going to square it. Okay, so the square root of a square is itself, and negative 9 squared is 81. And we're going to subtract our 10 across, so we have x is equal to 71. Let's check it. So we want to do the second function, square root of 71 plus 10. We want to end our radical, and then we want to add 9 to that. And it gives 18. See how that didn't work? Okay. Now why didn't that work? Well, way back up in here, when I had the square root of x plus 10 is equal to negative 9, I could see right there that nothing that I could put in here can ever make a negative number. Okay, so there is no answer to this one. So you can kind of see what I'm talking about when it produces these extraneous roots. They don't work. So you really have to check every single answer. Okay, so here, this is the symbol for the empty set, meaning there is no solution. All right. So you will get those, or if you get 2 answers, you might have to throw one of them out. So you have to check everything. Okay, now we have a radical sign on either side, which is good. All right. So if I would square both sides, I'll get rid of both of the radicals. Why? Square root of a square is itself. Square root of a square is itself. This turns into a super easy linear problem, doesn't it? subtract my 4y across, so this is gone. So I have just a y plus 5 equals 6. Subtracting my 5 across gives me y equals 1. Well, let's check it. If I put a 1 here, then I've got 5 plus 5 for the square root of 10. And if I put a 1 here, I've got 4 plus 6 for the square root of 10. So square root of 10 equals the square root of 10, so that one does work. Why is it so hard to get in there? Okay? All right, what is going on here? Well, let's see. We have q squared minus 2q plus 36 is equal to q plus 6. Well, again, I got to get rid of this radical. I'm going to square both sides. So the square root of a square, that's going to wipe out this whole big thing. So all I have left on that side is the q squared minus 2q plus 36. And that is equal to, okay, so this is a FOILing problem. Don't get caught up into, we know how to do what this means. That means this. So first terms are q squareds. Outside is a 6q and inside is a 6q, so I have 12 q's. And my last is a positive 36. Okay? I'm going to want to solve for q. So I'm going to subtract my q squared, which will just get rid of them completely, right? These are gone and these are gone. So all I have left now is negative 2q plus 36 is equal to 12q plus 36. Okay? Now I want to subtract my 36 across, which will get rid of these two and these two. So I have negative 2q is equal to 12q. So I'm going to get my q terms together, plus 2 q's, right? This becomes a 0, and I've got 14 q's here, and I divide through by 14. So q has to be equal to 0. All right, well, let's plug it in. Wherever I see a q, I'm going to put a 0 in there. I'm going to see if it makes a true statement or not. Okay, so I've got 0 squared minus 2 times 0 plus 36. And that has to equal 0 plus 6. Well, these two are gone, right? And that one's gone. So all I have left here is a square root of 36 is equal to 6. Square root of 36 is 6. So that checks. Okay? So we have 0. Well done. Okay. And then my last one. I'll do all of these for you today. If there's only 5, I can do all of them. All right. Now, I have a double radical, but I got this pesky 5. So if I subtracted that one across, it could have looked like that one, except it's got the 5 there. So it's not quite the same. But in any case, when I had this, I had the double radical here. I had one on either side. I could just start by squaring. Well, that's kind of what I want to do here, is I want to drag one of these over. Okay? So I'm going to just choose to drag this one over. It doesn't really matter which one you pick. I just don't want them on the same side. So now I have the square root of x minus 8 is equal to 5 minus the square root of x plus 7. Okay? Now I'm going to work on getting rid of this radical sign. So I'm going to square it. I've squared this side, so now I have to square this side. The square root of a square is itself, so this side is fairly straightforward, but this is not. This is a FOILing problem. Do you have a FOILing problem? I have a FOILing problem. Okay? X minus 8 is equal to, first terms, 25. outside terms. I've got a negative, because I've got a positive times a negative, so I got negative 5 roots of x plus 7s. My inside term is the same. I got negative 5 roots of x plus 7s. My last term, it's a negative times a negative, so I'm going to have a positive. And I'm going to have 2 of these. All right? So I'm going to have x plus 7s, and that's going to be squared. I'm going to go way over here now. I'm getting down to the bottom of my screen, which is very unfortunate. Oh dear. Okay. Might have to, I don't know what I'm going to do. All right, so I've got x minus 8 is equal to, all right, I've got 25. That's this one right here. I've got negative 10 of these. Negative 5 of something and negative 5 of the same is negative 10 of those. It's gonna be, I'm going to have to erase some stuff here. And then I've got x plus 7. Square root of a square. See how these are matching? This comes out. All right. Now what do I want to do? Well, now I think I want to get everything to one side except my radical, because remember how in the beginning we said we need to isolate our radical. Now I've just got the one radical. See, when I have 2 and I've got more than this, just the 2 going on, then I'm going to have to take the square twice. Okay? So let me see if I can't get rid of some of this for you. Get rid of all of this. I don't want to get rid of too much here. Yikes, I'm going to get rid of that. It's kind of a trick, isn't it? Kinda. Alright, I can just, okay, so now I'm going to go back in here and see what I got going on. Alright, now I got some room. Alright. So what do I want to do? Well, first of all, I can combine these. They're on the same side. And I can subtract an x across. That's going to wipe my x terms out, isn't it? Both sides. So now I have negative 8 is equal to 25 and 7 make 32 minus 10 roots of x plus 7s. Okay. Are you going to subtract those two? Better not. Let me come up here. So I've got negative 8 is equal to 32 minus 10 roots of x plus 7s. So I'm going to subtract my 32 across. Okay. Now I have negative 40 on that side. These are canceling. Negative 10 x plus 7. And then I would divide through by negative 10. So here we have a positive 4 is equal to x plus 7. Okay, I've isolated my second radical. Now I'm going to square both sides. Square root of a square is itself. 4 squared is 16. Subtracting my 7 across. 9. Let's see if it works. Okay. If I have the square root of 5 times 9 plus 5, equidecimal, let's see if it matches on that side. 4 times 9 plus 6. Ah! It doesn't. It doesn't make a true statement. No, I'm going to shoot. Now I have whoops. Oh dear. Well, no wonder I'm in the wrong problem. Good grief, Simone. All right, well, I sure, okay. How did I get back to number 3? This is number 5. Let's check this one. Well, no wonder. Okay, silly, silly, silly. Square root of 9 minus 8 plus square root of, come on, 9 plus 7 gives 5. Whew. That kind of scared me there for a second. I didn't think I did anything wrong. It helps to check it in the right problem, doesn't it? Sure does. So we have a solution set of 9. Okay, and that's it. Obviously, there's more to this. I've kept the numbers down so that we can squish in 9.7. I think it's very important for you to have some sort of exposure to complex number system. And that one will be short as well. I think I don't know how many problems I put in there, but not as many as I normally would. So start solving with radicals. Make sure you check all your answers because some won't work. And I'll see you for the last section, 9.7.